Today we'll learn about reinforcements and their forms in the advanced composites thermoplastics manufacturing processes. Most plastics today are available beyond their pure state. If you remember from the very first module, when we talked about, we said polymers are the pure state of the materials, and then plastics, which are polymers plus something else, are the impure state. So basically, plastics are beyond the pure state of polymers. And this is because they do this on purpose so that we can impart some special properties, whether it's to enhance the mechanical properties or to provide some additional characteristic or features for the materials. And there are a lot of classifications of these, whether we call them as reinforcements, fillers, additives, and so on and so forth. Each of them have a specific purpose, and that's basically what we will learn in this course module. Two basic categories of additives that we'll be learning today are reinforcements and fillers. Reinforcing fibers increase the mechanical properties. The primary purpose of reinforcement, the very first thought that you should get in mind when we talk about reinforcement, is that they do enhance the mechanical properties significantly. And when I say mechanical properties, it could be a combination of these to stiffness, strength, toughness, and energy absorption, or even the strain and break, a combination, one or a combination of these things. So a reinforcement can be considered, or may be considered as a filler. But on the flip side, a filler, these are additives which are primarily used to reduce the cost. For example, if you have an expensive polymer, and if you would like to use that polymer in a certain application, but your cost limitations doesn't allow to use that polymer as such, then what you do is you add some low cost fillers to just fill the gap, and you can reduce the overall cost of the material. But in this process, the fillers may enhance certain properties or certain mechanical properties such as stiffness, strength, or whatever. But the primary purpose of adding a filler is not specifically to enhance the properties, but to reduce the cost. But in the process, they may actually enhance certain properties. So a filler need not necessarily be considered as a reinforcement, but it may actually provide a value as a reinforcement in plastics. So for many applications, the polymers or the plastics, which again, as I said, I will be interchangeably using these just for simplicity, but they do have specific definitions that we talked about in module 1. So for many applications, polymers are not always ideal due to the dimensional stability that is required or the strength that is required. They do have some special characteristics, but that may not be enough for someone to apply them directly in a specific application. Even if you take the case of an automobile, a lot of the interior pure state of the polymers is never used. So we oftentimes add these fillers and fibers, just as I talked about, whether the reinforcements or the fillers or any other additives, to provide that additional enhancement in the characteristic properties that we are looking for. Reinforcements can be in the form of fibers, viscous, or particles. So adding fibers to polymers will significantly improve the properties, but adding viscous and particles, they do have special geometry, which we will talk about in a minute. They may not necessarily provide a significant enhancement in the properties, but they may provide incremental enhancements. But on the flip side, the fibers do provide significant enhancement in the properties. Reinforcement is a discontinuous phase in a composite. So when you actually take about this plastic plus these additives, whether it's the reinforcements or the fillers, then from hereafter we term that as composite, because a composite is a multi-phase material where you have phase 1, which is, or the dominant phase, which is primarily the matrix. In our case, in this whole curriculum, we are talking about polymer base, so plastics, which is the dominant phase, and then there is a secondary phase, which is basically the reinforcement or the fillers. So it could be discontinuous, or it could be in a different fashion. Again, it is a discontinuous phase, but we can also show having a continuous fibers, which again I'll show in few slides. So reinforcement is a discontinuous phase in a composite. The primary role of this particular discontinuous phase is to provide the strength, stiffness, and multiple other mechanical properties. It could also add on some energy absorption or strain and break or toughness, fracture toughness or impact toughness, a lot of other combination of things. So when you look at this whole composite as such, right, for any component, whether it's applied within the interior of an automobile or an exterior or any other application, aerospace or consumer products you take, right? Whenever you're designing a component per se, the component, when you apply an external stress, let's take an example of a bumper, right? When the car hits in a collision, there is a stress that is being transmitted to the bumper. The very first phase within a composite, or if the bumper is made out of a composite, the very first phase that experiences this external load is the dominant phase, which is the polymer. Now, as I said, the polymer doesn't have enough strength, right? In the last slide, we looked at it. Many times we cannot use pure polymers because they don't have adequate strength to meet the performance requirements. So since the polymer doesn't have enough strength, it transmits the externally applied load to the discontinuous phase, which is the reinforcement. Now, these reinforcements, which have high load bearing capability, they basically withstand these external forces and then try to resist them up to a certain limit. That's how they try to battle the war between in this particular platform. So if you consider, and how does this whole stress transfer occur? So if you consider this to be your reinforcement, and then this is the polymer that is engulfing the reinforcement, and now we have an external stress that is being applied, the polymer or the plastic experiences of very first the polymer or the plastic is the dominant phase, which experiences the external load, and then it transmits the load to the reinforcements through what we call as interface. Now, if there is a gap between the reinforcements and the polymer, that means there is no good compatibility between these two. There is a gap here. Then the load transfer may not be so much effective. But if they are compatible and there's a good perfect bonding between the polymer and the reinforcement, then there's an effective load transfer. So the interfacial region or the compatibility between the reinforcement as well as the polymer also do play a very important role in this whole load bearing situation. So what is this? This is a schematic of a reinforcement. It has a very longitudinal axis, and then this is basically a cylindrical reinforcement, and you have a coordinate system. Which coordinate system is this? This is an activity that you can do towards the end of the class module.